Assalamu alaikum wa rahmatullahi barakatuh. So today we'll be going through another video for your alternative to practical paper 6 paper for physics, which is on the 19th of May, and we'll be going through the common mistakes in the electrical circuits and the questions regarding it, especially like in electricity chapter. So the first mistake is in the category 1 for normally electrical circuits. So the first mistake is forgetting units, such as for voltage, which is just a V, then for current, ampere, and then for resistance, ohms. So this is usually the mistakes. Students often leave out units in tables or final answers. They write 2.5 instead of 2.5 volts or 0.8 instead of 0.8 amperes, which loses the marks even when the numerical value is correct. You need to know that if your answer is 2.5, which is correct, and in the marking scheme it's 2.5, but you don't write the symbol, if it's asking you how much voltage and it's 2.5 voltage, but you don't write 2.5 V, and or if it asks you ampere, 0.8 ampere is correct, but if you don't write 0.a, the symbol A, then your final answer is wrong and you will not get any marks. So what's the solution? Every number in table headers and final answers must include the units. If they ask you, like include the units in the table or something. No naked numbers allowed. Write units in column headers if asked, and beside every calculated value, unless it's already given in the question. So examples, as I said before, always check your work for missing units before submitting. So here's an example. So this is a question from a past paper. Her readings are shown in table 2.1. We don't know who her is, but we can just assume it's someone. Yeah. So add units to the column headings in table 2.1. Now, if you see this is, you have to add units to the column table. Okay, so you know that you'll have to add it somewhere in this, and this. So you cannot, even without knowing what the experiment is about, you can tell that this is something about the cooling rate, right? So if you see T, that's usually time, right? Time. So time is usually in seconds. So your unit over here will be S, because time is over seconds. And then you see this, right? When you see a symbol like this is for theta. Sorry, not theta, this is for temperature. This is for temperature, right? So temperature, the usual unit, SI unit, is degree Celsius. So your unit over here will be degree Celsius. Many people don't forget to read this whole thing, and then they lose the marks because of this. And 1 mark, obviously, in ATP you need to get above 32 out of 40 for A or A star. Okay, so now the second mistake, incorrect diagram symbols, drawing non-standard circuit symbols. I made a reel about this on Instagram, and the mistake is that they draw non-standard symbols, such as placing a voltmeter in series instead of parallel, or drawing the cell battery backwards with incorrect polarity markings. This is an example. And the fix is that memorize the standard circuit symbols. Many people, when they're drawing, example, the variable resistor, they draw it maybe like this, or like this, the arrow, something like this. Is completely wrong. You need to know that the variable resistor, it looks like this. That's a variable resistor. And then example, if you have a circuit like this, then if you have example point Y and then point Z, this is just an example, and you want to measure the voltage as going past, you always connect the voltmeter in parallel. You don't connect voltmeter like this, you have to connect it like this. Then for current, you have to connect it in series, so current will be like this, it will not be like this, because current is always in series, so this will be wrong, this will be correct. Okay, so these are some of the examples. So I made a list of the possible of actually all the possible circuit symbols that they could ask you in ATP in paper 6. Mostly they ask you about voltmeter, ammeter, fixed resistor, variable resistor, thermistor. Okay, this is my bad, this is wrong. Thermistor, LDR, and diode, LED, stuff like this. They usually don't ask you about anything else like potential divider or power supply or any of these. So yeah, in thermistor is like this. Okay, there has to be, this is a thermistor like this. Okay, LDR. Okay, so just no ammeter, voltmeter, fixed resistor, variable resistor, thermistor, LDR, LED, diode, to be safe. And maybe potential divider as well, also very important. That's it. That's what mostly comes. Okay, now calculation errors. Obviously, like the mistake is that students misread calculated displays or mix up the operations. Common errors include confusing division with multiplication or misreading scientific notation on the screen. So the fix is always show your calculation steps clearly. If you have any question, first write the steps. Okay, don't simply solve on your calculator. Example, even if you have 2 plus 2, write it on your calculator and then write it on the paper, so that you're sure, so that you have a clear structure of what you're doing. Then if you have to add the 4 plus 2, then you keep moving. Okay, write it on the paper. Keep at least 3 SF significant figures throughout your working. I would say don't round it at all, but if you want to, just do it to 3 SF. And then only round the final answer. And then if they say usually to 2 SF, it's usually 2 SF. But if they say anything else, like if they ask in the question specifically 3 SF, 2 SF, 1 SF, 1 DP, 1 decimal place, then you have to do it according to that. Otherwise, usually 2 to 3 SF is fine. So example correct, like example resistance is voltage over current, and if you have 3 volts and then 0.12 ampere, and you want to find the resistance, that'll be 25. But some may write it as 2.5 because they may say, oh, it's 3.0. They may confuse that 0.3 or maybe 30 or something like this, or maybe they may consider 1.2. So just make sure, just keep check. Just check to make sure that it's correct. Check twice. Okay, now we have mistake category 2, which is generally ATP mistakes. Okay, misreading graph scales and not using the gradient calculation points. Okay, so these two literally can cost you 4 marks or 5 marks if done completely wrong. And as I said, you need to get above 32, so it's really important you get these easy questions correct. Okay, so I'll show you these two in this example. I did this paper on my YouTube channel in the first video. This is May-June 2025 paper 6-2. So in this, they have asked you plot a graph of V over centimeter cube. Just so you know, V over here is volume and H over here is height. So they have clearly asked you plot a graph of V over centimeter cube in y-axis, so you have to do it in y-axis, and then H over centimeter in the x-axis. Okay, then they have said start your axis at the origin, so you have to start your line from here, like this, somewhere like that. Okay, and then draw the best fit straight line. Now in this example, they have told you draw the best fit straight line, but in other questions they may say draw the best fit curved line. In curve you will draw something like this, like this, like this, like this, like this, like this, like that, like something like that. Okay, and then in straight it's like this, completely straight, either like this, like this. These are like straight lines. Okay, something like that. Now if they don't say anything, let's say they don't say anything, they say, wait, let me remove this. They say draw the best fit line, then you have to follow what the pattern, what the line is saying. Example, if it says if the graph shape is like this, the one shown the plotting, then this looks like a best fit straight line. You just have to draw to at least 2 to 3 points. But example, if we had 1 point here, 1 point here, no, example, we have 1 point here, 1 point here, 1 point here, 1 point here. No, I think this is, wait, I'll give an example like this. You can see like how it's curving slowly but surely. So you'll draw something like this, like this. Okay, that's just an example. In the best fit curve, in the best fit curve line, you usually have to do all the points, but if you don't, then it's also fine. But in the best fit straight line, you need to get at least 2 points. So in this case, I have plotted the graph. Also, it's really important you choose a suitable scale. Many people don't know this, that you have to cover half of the grid. So example, we have 0 to 60 in this portion, 0 to 60, and this is V, right? So in V the maximum is 47, meaning 47 has to be, in this case 47 is over here, 47 has to be more than half of the grid. What do I mean? I mean that till this part, till 30, from 0 to 30, this is half of the grid, and then this is the other half of the grid, 30 to 60. So 47 lies in more than half of the grid, which is fine. But example, if it were 47 came somewhere here, if this was 47, that means the maximum point, which is this, would come somewhere here. So then the graph would look like this, right? And then the graph would look like this, something like this maybe. And then your line will just be this. Now look, that does not cover the more than half of the grid. This is the full grid, right? This whole thing is the full grid, and then your graph is only covered in this much. So your answer will, obviously that's not correct. In fact, it will mess up this question, and then this question as well, probably, because all of these are related, gradient and then this. So yeah, it's important to keep that in mind. Okay, choose a suitable scale. For example, till here it's 47 maximum, so you can choose a scale like 10, 20, 30, 40, 50, 60. It covers more than the grid, so it's fine. Then you plot the points. It's also really important, check the plottings again. When you're done, check the plottings. You should have extra times for checking. Check the plottings, okay, because it's really important. Then finally the gradient. For the gradient, when it says show all the working and indicate on the graph the values you use. Example, if I have a straight line like this is a straight line, okay, just ignore the actual shape, okay, and you have to use a ruler in the actual exam. So example, if I have a straight line, and then the working is that you use the triangle method. The triangle method is that you take one point and then another point here, and then you do this and this. That's a triangle method. And then this will be your y2, x2, and this will be your y1, x1. We know that the gradient formula is y2 minus y1 over x2 minus x1. So whatever your y2 is in this point is, and your y2 and x2 is in this point, and y1 x1 is in this point, you just take that, plot it in, and you get your gradient. That's it. But you have to show this method, and the gradient can obviously differ because everyone's graph is not the same. The scales can be different, but it has to be around the same. They may give a range as well, so it has to be in that range. So those are the most important mistakes that people make, like not using the gradient calculation points, picking the wrong points for the calculation. So the mistake is that picking table points or points too close together for gradient calculation, and the solution is to pick 2 points on the line of best fit, not from the data table, at least half the line length apart. Mark points clearly and show the change in y, change in x, which is just y2 minus y1 over x2 minus x1. And that's it. And also you can use this, that choosing bad scales or misreading axis values leads to wrong gradients. Use scales that allow reading values within half a small square. Avoid inconvenient multiples. Pick simple scale values like 1, 2, 5, 10. Don't pick complex like 0, 7, 14, 21. Choose simple ones like 0, 5, 10, 15. So that's it. Thank you so much. This was a short video. If you have any questions, then ask them in the comments below. Thank you. And keep practicing your papers, and inshallah you will have a good paper for paper 6, because it's the easiest to score marks in.